Hello everyone, my name is Stijn van Vertigem and I'm a Senior Technical Product Manager at VMware's Network and Security Business Unit. Today I'll give you a quick demonstration of end-to-end segmentation across the data center and across branches using VMware NSX SD-WAN by VeloCloud as well as VMware NSX 6.4 in the data center. If you want to learn more about the end-to-end segmentation use case or you want to learn more about the benefits of VMware NSX SD-WAN by VeloCloud or NSX, I would recommend to read the blog that is accompanying this demo. So throughout this demo, I'll be using a healthcare customer called Elastic Sky Healthcare. And here you can see a very much simplified diagram of their network. On the right side, you can see their headquarters in which they're running VMware NSX and they're hosting all of their applications. On the left side, you can see a couple of branch offices. These are hospitals. There's the Denver branch, the Tokyo branch, and the Brussels branch. Connectivity between these different branch offices and the headquarters is provided by VMware NSX SD-WAN by VeloCloud, which does not only ensure that the best path is used on a per packet basis across both public and private links, but also provides a secure overlay between all different branches. And on top of that, provides segmentation, which can be distributed across the branches. And that segmentation piece is exactly what I'll be demoing. In this demo, you'll see a couple of users, starting with Ellen, who's a visitor in the Tokyo hospital. Then we also have Bob, who's a doctor in the Brussels office. And finally, we have Jane, who works with the IT department from the Denver branch office. In the first demo, we'll have a look at how Ellen, who's a visitor in the Tokyo branch, is using her iPad that is connected to the wireless network in order to try to access a hospital kiosk application that is hosted in the Washington, D.C. headquarters. And in the second demo, we'll have a look at how Dr. Bob, who's in the Brussels hospital, is using a remote session to a desktop that is hosted in the Washington, D.C. data center in order to access his EMR medical records application. And finally, our IT user Jane in Denver is going to be doing some troubleshooting in order to help both Ellen and Bob access their applications. So let's start with Ellen, who's in the Tokyo hospital at Tuesday, 9:41 a.m. And she has her iPad and it's connected to the guest wireless network in the Tokyo hospital. And she's attempting to access the kiosk application that is hosted in the Washington, D.C. data center. But as you can see, the website to the kiosk application is not loading. So next, our IT user Jane is informed. She's based in Denver and she's informed of the issue, so she needs to go and troubleshoot this. Jane uses the VMware Horizon client on her laptop to access a remote desktop session. Now the first thing she does is check connectivity. For that she uses the VeloCloud orchestrator and she sees that the Tokyo branch is online, is connected, and on this page you can also quickly see what the top traffic, the top applications are. Now she clicks on Remote Diagnostics to troubleshoot the problem, and she decides to run a router table dump. Now here you can see that multiple segments exist on this Tokyo branch. There's the global or corporate segment, a guest segment, and a PCI segment. Ellen, who is a visitor in Tokyo, is connected into the guest wireless network. And looking at the routing table, we can see that the route to the application that Ellen is trying to access, which is on 172.16.10.0 network, is missing. Now, in order to ensure that the routing has been set up correctly, Ellen goes to check the configuration of the Washington Data Center VeloCloud Hub. So she selects the Washington Data Center HQ edge here, goes to Device, and here you can see that also on the Washington Data Center we have multiple segments. Again, the global segment, the guest segment, and the PCI segment. We go to the guest segment and let's check the routing configuration. And here you can see that at the data center side, this edge is pairing with this 192.168.151 IP address, which is an NSX ESG. Now Jane needs to confirm that routing has been correctly set up on the NSX ESG. So she logs into vCenter, goes into Network and Security, and goes into NSX Edges. Here, Jane selects the guest edge and then goes to the routing tab. And here she sees that there's only one BGP neighbor setup. And this BGP neighbor is the DLR, so no neighborship relationship has been established with the VeloCloud edge. So in order to do that, Ellen quickly configures the IP address of the VeloCloud edge guest segment, as well as the remote AS, and publishes these changes to the NSX edge. Now, as soon as publishing is done, routes should be propagated from the NSX edge to the VeloCloud hub, as well as to the VeloCloud edges at the branch locations. So let's confirm that. And now you can see the routes here for the 172.16.10, 20, and 30 subnets, which are the subnets for the different tiers of our guest applications. So now let's go back over to the Tokyo hospital, and let's see if our visitor Ellen is able to access the kiosk applications. And as you can see, this time the application comes up fine. Now let's have a look at our second demo, and in this scenario, our Dr. Bob, who's located in the Brussels hospital, is trying to access his patient record application through a remote desktop. He's accessing the remote desktop through Horizon View, but as you can see, the OpenMRS app is not coming up. Now, before a doctor opens a ticket with IT, he decides to check if his iPad is actually connected to the employee wireless network. And here you can see that he's indeed connected to the Brussels branch employee wireless network. So once Dr. Bob opens a ticket, it's again assigned to Jane, who goes on to troubleshoot the issue. Jane knows that NSX 6.4 is used in the data center to provide access to applications on a per-user session basis. For this feature to work, NSX integrates with Active Directory and allows for distributed firewall rules to be configured on a per-user group basis for both VDI and remote session use cases, in which multiple users may be connected to the same remote host. This is why Jane and other members of the IT staff are able to access the infrastructure management interfaces. Jane knows that another policy should be in place to allow doctors who are logged in from a branch hospital to a remote host at the data center to access their applications. Jane logs into her remote desktop, from which she has access to the data center management tools. Jane first checks LogInsight, which is the central logging tool. Amongst many other logs, the distributed firewall logs are collected here. Now, Jane is interested in seeing why Dr. Bob isn't able to access the medical records application. She knows Bob and other medical staff are a member of the EMR Active Directory group, so she creates a filter based on the security identifier, or SID, of that EMR group. Now Jane opens Interactive Analysis to see the actual logs, and then goes to the field table, which gives the most clear overview of the incoming distributed firewall logs. So these logs have been filtered on the Active Directory group that our doctor belongs to, and as you can see, these are drop events. So the distributed firewall dropped this traffic, and you can also see the firewall rule ID here that generated this log, and this is rule 1048. So now Jane opens up vCenter and goes to the Firewall tab, and she sees a rule here matching the 1048 rule ID that was seen in the log. And she notices that this rule is part of a remote desktop section in the Firewall rule table. Now, in order for user session-based identity firewall to work, we need to make sure we enable this checkbox here, enable user identity at source, and this has been checked, so that's correct. Next, Jane checks if Bob's RDSH session has been correctly identified and if Bob has been added into the security group. And here we can see when Bob last logged into this particular RDSH host. Now Jane realizes that the reason Bob was not able to access the MRS application is that this rule action has been incorrectly set to block instead of allow. So Jane goes ahead and changes the action into an allow, and then publishes these changes to the distributed firewall in the data center. Now let's have a look and see if Bob can access the application. So Bob refreshes his screen here, and as you can see, the MRS application is loading correctly this time. So Bob can log in and look at his patient's records. Now Bob is a very curious doctor, and he tries to access a login site here through his RDSH session. But as you can see, that is being denied because the RDSH rule only allows the IT staff to access the IT infrastructure. And that concludes this demo.